Hello, my name is Arnav Tiwari, and this is my Lab 4 on oscillations. The purpose of this lab is to analyze the motion of a spring mass system in which the mass moves with both vertical oscillations and swinging. For this experiment, we'll be tracking the system using Tracker and then comparing its motion to a computational model built in GlowScript. We will look at energy graphs and x and y displacement graphs to ensure the accuracy of our model. The outcome of this experiment is to prove that total energy remains zero and the energy principle is proven. The system is our moving spring system, and our surroundings are just the atmosphere. The fundamental principles that are explored in this experiment are Newton's second law, which states that the change in momentum is equal to the net force applied, or is at least proportional to the net force applied, and energy principles, as with a system's total energy change comes from the work done by external forces and any thermal energy exchange with the surroundings. Here is my tracker data. As you can see, I have both X and Y oscillation data, and on the left hand side you can see the actual individual points that we tracked with the origin at the top of the system where the string is at 0. Here's the initial conditions for our computational model. As you can see, the mass is 0.402. We have a position and velocity vector with the velocity at 0. We have gravity, the k of the spring, as well as L0, L naught. We then calculate the L value by doing position minus the spring position. Then we calculate L hat as well as S, so we can calculate our spring force, which we do in the next lines where we calculate kinetic energy, potential energy, as well as total energy. Here is the calculation loop. I start by doing while time is less than the total time, which was 10.192. We redefine the initial conditions, and then we get into the calculations with the force of the spring as well as force of gravity to calculate F net. We then use Newton's second law to update the ball's velocity and ball's position. And finally, we update the spring, once again with calculations that we did previously, calculating L hat, and S, and we calculate the total energies with K, potential energy of gravity and the spring, finally adding all the energies together to plot our energy graphs. Comparing the computational model to the experimental procedure, we can see that they are very similar. In oscillation periods, the graphs overlap for the entire period, proving the accuracy of our computational model. Some possible errors in this experiment was that there are external forces doing work on the system like air resistance and gravity that we did not account for. The system is not fully isolated, which could cause slight deviations in data. There could be slight errors with the tracker measurements because I might have not always put the tracker in the middle of the objects, which could again cause slight deviations in the data. But overall, the outcome of the experiment would remain the same. The energy principle, the big question, what does it mean? Is it proven or not? Yes, it is proven because the delta E, the orange line on the graph on the left here, is 0, meaning no external forces are changing the total energy of the system. Now calculating the period of oscillation for the x and y directions, I took 3 consecutive periods and found the average time between them. And as you can see, for x and y, they deviate by around 0.9 seconds, proving that different directions give different periods of oscillations, which impacts the graphs and the overall spring constants of the system. That's all I have, and thank you for listening.